careful about your words. You know, like positive, different, increasing. One of your problems. So I'll do I'm going to start the first couple here. If f of x is increasing, what do we know about the derivative then? Positive or increasing? Positive. Positive derivative means that the slope is positive on the original, means the original is increasing. If f prime is negative, so f prime is below the axis, what do we know about the original? Decreasing. If f double prime is positive, so the second derivative level, what does that tell us about the original? Concave up. I'll stop there. So keep going up here. How many got those first three right? Keep going. Alright, so let's just talk through these then. So if the second derivative is positive, what is true about f prime? So this is a little tougher one. If the second derivative is positive, what does that mean about the original? It's concave up. So we did that in number 3. And if it's concave up, and I want to know what's happening to the derivative, that means I want to know what's happening with the slope. Well, if it's concave up, what is happening with the slope as I go? It's increasing. Second derivative positive means the original is concave up. And then what's happened with the derivative is the same as what's happened in the slope. And if you read across, your slope will be getting bigger as you go. So this one's increasing. Point of inflection on f of x. So, like that. Then f of x switched from, and this is, it's either up to down or down to up. So you could do up to down. Or you could do down to up. It just changed concavity. I don't care which direction you want to say it. F prime of x switched from. So let's just pretend we're switching from. It's a point of inflection. And ask this very well. Let's pretend it's this. So it's a point of inflection in that direction. Some of you might have to like recalibrate your answers, I guess. But so if this is the situation and this is f of x, then f of x switched from 1 to 1 at this spot. This graph that I'm looking at changed from 1 to 1. You said, I thought you said it. Yeah, concave down and concave up. So isn't it concave down prior to that and concave up after? Alright, what did f prime do at that spot? This is the tough one. So I want to know what the derivative does at that spot. What does it switch from? Positive. Good. So the derivative is the slope. Prior to that spot, our tangent line, like the slope of that is, as I go along, the slope gets smaller, 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 smaller. Once I hit that point, it flips, and now my slopes start to get bigger, and I start kind of climbing back up. So f prime in this case would switch from decreasing to increasing. And then f double prime, well, if we switched from concave down to concave up, f double prime must have switched from negative to positive. This is kind of, I mean, that's kind of everything. These two are the tougher ones. If you can do those, you should feel pretty good. Am I going to get all number 5 correct? Questions I can answer on the first 5? Alright, in 6, there's a relative min on f of x. So, this is f of x, and I've got a point down there. So f of x switched from decreasing, we're going down to that point, to increasing. The derivative switched from what to what? Well, if I'm decreasing, what's true about my derivative? If f of x is decreasing, what's true about the derivative? It's negative, right? And then if f of x is increasing, it's positive. So f prime switched from negative to positive. That's the same thing as saying slope switched from negative to positive. Isn't that what happened? The slope was negative, the slope was positive. That's why we get this positive. And then f double prime, well, if I have a relative min, if I'm in this bowl, am I concave up or concave down? Concave up, which means the second derivative is positive. Questions on any of that I can go through again, help with, re-explain, find a different way? Okay, let's start looking at that packet then. So this is the packet that your next test will be based on. We're going to spend a lot of time going through it in class, and then your test will be questions from this, where I just tweak the question a little bit. So you can't just memorize the answers. So we're going to just go through them together to start with. Try the first one. Try number 10 right there. So you need f of x, f prime of x, and f double prime of x to all be negative. What is f of x negative tell us? Below the axis. I got to be below the axis. So right away, I guess I can cross off e. F prime of x negative means decreasing. So it's got to be decreasing the whole time. So that is not decreasing the whole time. Neither is that. So I'm down to those two. And then f double prime negative means concave down, right? What would it be? Questions? Question or you have it? Okay. Try the next two. Well, let's go through these together. This is the first time you've seen these, I guess, so they're a little tougher for you at this point. Okay. So now we get into, they're giving you derivative graphs, or even second derivative graphs. You got to be able to read that, interpret it, and kind of back up the information they want. So this is a derivative graph. So when this graph is above the axis, what is the original graph doing? These y values represent slope. these y values are above the axis, the slope is positive, right? On the original. So what's the original graph doing in this range? Increasing, and what's it doing here? Decreasing. So go ahead and answer the question. I'm going to ask you other questions too. Where is f of x concave down? Find the tangent line. So this is number 7. I'll call this number 8, number 9. 10. Number 7, the original one we started with is B. It's increasing from -2 to 0. F is increasing from -2 to 0 because we're above the axis here from -2 to 0. So the question they asked you, number 7, is B. How many number 7, right? Cool. Try 8, 9, and 10, but my version. Alright, so let's look at the ones I asked. So where's f of x concave down? Well, concave down means the slope is decreasing. Like, that's the definition. Well, that would mean f prime is decreasing, because slope and derivative are the same thing. Well, this is f prime. So where this graph is decreasing, that means the slope on the original is getting smaller, and if your slope is getting smaller, that's when you're bending down and making that concave down shape. So this should be from -1 to 1. So this is concave down. What's this part then? Concave up, which creates what at x equals 1? That creates a point of inflection. So I can answer that one there. Questions on 8 or 10? And then the tangent line, I think we did one like this yesterday. You got your basic tangent line formula. 2 and 5 go in these two spots. What goes here in general is the slope. Well, our graph of the derivatives is a graph of the slopes. So what is the slope of the original graph when x equals 2? It's 0. So the y values on this graph represent the slopes on the original. So the y value here is 0. So we're on the x-axis, that represents the slope of the original. That would be your equation. Questions on anything I just did? And there's tons more of these. Like, we're going to practice this for quite some time. But anything I can help with now? Alright, on the next one. So, what we got? Okay, second derivative. So, second derivative, what information are we getting from this? What does second derivative tell us? There's like 6 of you mouthing the word concavity. If you can just use your vocal cords with the mouthing, that'd be phenomenal. Second derivative tells us concavity, right? If the second derivative is positive, what's true about the original graph? Concave up. So if we're above the axis, what's true about the original graph? Concave up. If we're below the axis, concave down. So the original graph is concave up here, down, up, and up again. It actually doesn't switch right there. So is x equals, what is that, a right there? I kind of wrote over. Does that say a? Is that a point of inflection? It is. Second derivative was positive prior to that and negative after that, which means the original graph was concave up prior to that and concave down after. So A is. What about 0? 0 also is, because we're changing concavity at that point. It's down to the left of that because we're below the axis, and it's up after that because we're above the axis. What about K? Is that a point of inflection? It's not, because we're concave up on both sides of it. What about M? Nope. What they're trying to do here is M is a point of inflection on this graph. Well, what level would that actually put us at? If we looked at a point of inflection on the second derivative graph, what level are we at now? We're at the 4th. Because point of inflection is like the second derivative of what you're looking. This is like Inception, right? Like dreams within dreams within dreams. It's like derivatives on top of derivatives. So that's what they're trying to get you to put. Like, look at this graph and choose the point of inflection, but that's not what's going on. And then is that a point of inflection? Because we didn't really change concavity. So it's A and 0. So A. I didn't really give you guys much time. How many already have that? Alright, take a minute to try 90. Yeah. The last one? On what? Okay. Oh, sure. Yeah. Step into my office. Just try the 3 on the next page. We'll just do like, instead of 1 at a time, we'll try to do chunks. The top one's hard. I think the first one's hard one. So, the original graph, we're looking at the tangent line, x equals 2, y equals 5. So x equals 2, y equals 5. So I want the slope at x equals 2. So I have to find x equals 2 in the derivative graph. Yep. If you get 90 right, I'll be impressed. I know that's all very important to impress me.
He said it's easier if you go in and do like the first semester one, and just do that for everybody, and then go back and do the second semester for everybody. So it's faster.
I don't know.
Like maybe. I mean, it's not crazy, but
Not bad though.
it'd be easier to just
Yeah.
click a button.
Yeah.
But I know the technology.
Maybe next year. Gotta hire Nick. Alright, let's look at those three. So the first one is just to give you an idea of, when I give you the test, I'm going to reuse these questions. But I'm going to change like one or two words just to make things, so I could make this say positive first derivative and a positive second derivative. So I'm just changing like a little tweak like that. Keep the concept of the question the same, but that way you're not just memorizing like, number 15 is B, So you memorize concepts, just not the actual answer. So positive first derivative. What does that mean? It has to be happening with the y values of the original graph. They have to be getting bigger. So 7, 9, 12, 16, those are getting bigger. 7, 11, 14, 16, great, getting bigger. But these three, those would have a negative derivative, wouldn't they? Because they're getting smaller, you got a negative slope, they're decreasing. So then I've got a negative second derivative. So that means we are concave down, or the better way to think about it is that the slope is decreasing. That's what concave down means, right? Your slope is getting smaller as you go. So if you start taking the slopes between these points, and they're all x intervals of 1, which is nice. Like that one up by 2, right? That one up by 3, that one up by 4, and those are the slopes between each pair of numbers. So is the slope getting bigger or smaller in this one? The slope's getting bigger, so therefore it's concave up. So if you think about sketching a slope of 2, and then a slope of 3, and then a slope of 4, you're going to get steeper, and you're going to start making that U shape. Where here, it goes the other way around. So it goes 4, 3, 2. You start sketching those, you start to see like that upside down U shape or that N. That's not a decent amount of U with D, so that's good. Questions on that one? Alright. 76, where is F increasing? F is increasing when F prime is positive, so above the axis. So for this section here, this kind of drives me nuts. I don't like the way they answered this. I would have said negative 2 to 1 and 1 to 3. Because I would have said, okay, it's not really increasing at negative 2. Like, what's the slope? What's the y value at negative 2? Of this, it's 0. And that's not really increasing. And neither is that, and neither is that. But the closest thing to what I created is B. So they're just kind of saying, okay, let's chunk that all together. It's all above the axis. Dump that all at once. So, not in love with, but that's okay. How many would be there? Okay. Then the third one, so horizontal tangent lines, they're just telling you like where it turns around. That's why they give you that information. Like where it's flat, so you know like what it lines up with down here. Where's our relative maximum? So relative maximum is when the original goes from ink to deke, which means the derivative has to go from positive to negative. So right there. So that I guess is x equals 4. So C. How about C? Questions on that page though? Alright, we're gonna do this. So now that you've done some, I'm going to give you like a bigger chunk, have you do it for homework, and then I'll take questions on Monday at the start of class. I do the whole packet, but let's go up to and including page 10. Up to and including page 10. That's what you're working on now, and then your homework. I'll get an answer key up here so you can check your stuff. questions up here if you want to come and scroll through them. Monday, I'll come in and just go through them, answer questions, we'll go through them. This is supposed to be like a study guide / a way to help learn some more stuff.